All right, so this is the rest of the Unit 11 review for the final exam, which involves factoring. So we have already gone over this part, and now we're on the back side just looking at the factoring. So remember, first thing we look for every time we factor is a GCF. In this case, 2 divides into both of them, so 2 is my GCF. And there isn't a variable in both, so it's just 2. So I'm going to pull out a 2. And remember, we can divide each one of these by 2 to find out what goes on the inside. So 2 divided by 2 is 1, and there's still an x there. 12 divided by 2 is negative 6. Now, I should try to factor this, but since there's no exponent of 2, I can't go any further, and I stop after my GCF. Next one, again, we always look for a GCF first. In this case, 4 goes into both of them, and we should also notice that there's an x in both of them. So x has to be part of my GCF, and we take the smallest exponent, which is the 1 that's on this one. So 4x is my GCF, and then we can divide each one of these by 4x to the first in order to figure out what goes on the inside. So 8 divided by 4 is 2. Remember, we subtract our exponents, so it would just be x. 28 divided by 4 is positive 7, and 1 minus 1 is 0. Again, I would try to factor this, but if there's no exponent of 2, you cannot break it into 2, so you're done after the GCF. Next one, number 3. First thing I do is look for a GCF, but the first term here is a 1, so there's no number, and there's not a variable in all of them, so that means there's no GCF. And in this case, my first term is a 1, which means that we are going to use a t-chart. So remember, it's supposed to multiply to the last, which is 18, and add to the middle, which is 11. So 1 times 18 is 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work. So now I need to find one of these that would give me 11, and 2 and 9 combine to give me 11. And since these are all positive, these stay positive. So we have x plus 2, x plus 9 as our final answer for that one. All right. Number 4. Again, we should look for a GCF, but my first term is a 1, so that means there is no number GCF, and there's not a variable in all of them, so there is no GCF. Since my first term is a 1, that means that we're going to use a t-chart. So again, it's got to multiply to my last, which is a negative 24, and add to the middle, which is a negative 2. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work. So to get a 2, that won't work. This would be 10 and 14. This would be 11 and 5. But I can get a 2 here if I subtract them. And to get a negative 2, my 6 would have to be negative. So then this is x plus 4, x minus 6. All right, number 5. Again, I look for a GCF, but the first term's a 1, so no number. There's not an x in all of them, so that means no GCF. My first term is a 1, so that tells me that we have to do a t-chart. So we have to think about multiplying to the last, which is 60, and adding to the middle, which is negative 19. So we can make our list, right? 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 won't work, 8 won't work, 9 won't work, and now we're back to 10. So these are my options. So if I want to get 19, adding these would be 61, subtract to 59, add to 32, subtract to 28, add to give me 23, subtract and give me 17, add to 19, so I can get a 19 here. All right, so let's keep looking though. This would give me 17 if I add, 7 if I subtract, 16 if I add, 4 if I subtract. But now the issue is I want it to be a negative 19. So that means both of these have to be negative, so that a negative times a negative is a positive, and they add to a negative 19. So it is x minus 4, x minus 15. Next one, again, I would look for a GCF, but my first term is 1, so there's no number. And There's not a variable in all of them, so there is no GCF. Now this one, there are only 2 terms. If there's only 2 terms, we do the whole Squaresville thing, right? Are they perfect squares having their differences? Well, 144 is a perfect square, x squared is a perfect square. They're having their differences. So that means they go to their roots. The root of x squared is x, the root of 144 is 12, and they think about the good times and the bad times, and we have it factored. Okay, number 7. Again, the first thing we should do is look for a GCF. Well, 2 goes into 2, 2 divides into 8, and it divides into 96. So I do have a GCF this time, and it is 2. No x because there's not an x in all of them. So I can divide each one by 2 to find out my internal. 2 divided by 2 is 1, so we just take the x squared. Negative 28 divided by 2 is negative 14. Bring the x. 96 divided by 2 is 48, sorry. And now we have to try to factor the inside, because as soon as we see that there's a squared, we have to try to factor the inside. Since my first term is 1, this means that this would be a t-chart. So we have to think about numbers that multiply to 48 and would add to give us negative 14. All right, so 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 won't work, 6 and 8. I want to make sure you can see 6 and 8. So 7 won't work, and we've already done 8. So now we have to think about ones that would give us 14. Well, 1 and 48 is 49, and if we subtract 47. 2 and 24 is 26, and if we subtract 22. 3 and 16 is 19, and if we subtract it'd be 13. 4 and 12 is 16, and if we subtract we would get 8. 6 and 8 is 14, but we need them both to be negative to get a negative 14 and to give us a positive. So this is x minus 6, x minus 8, and don't forget to bring down your GCF out front. If you're missing the GCF, then your problem is incorrect. All right, number 8. So I look for a GCF, but 3 is the only number that goes into 3 other than 1, and 3 does not go into 2 or 1, and there's not a variable in all of them, so there is no GCF. Since my first term is not 1, this tells me that it's guess and check, right? So my only options that multiply to 3 are 3 and 1. My options that multiply to 1 are 1 and 1. So these have to be a 3x and an x. Then we would use our pencil to put the other one in, so 1 and 1, and see what happens. So 1 times x is 1x, 3x. If I want a 2, I could make the 1 negative, so 3 minus 1 is 2. So this would have to be a negative 1 there and a positive 1 here. And always check the last. Does negative 1 times positive 1 give me a negative 1? Yes, it does. So then my final answer is 3x minus 1, x plus 1. And the last one. So the first thing we do is look for a GCF. The only number that goes into 5 is 5, and it doesn't go into 5 or 3. There are no variables in all of them, so there is no GCF. So that means that since my first term is not 1, this is going to be guess and check. Well, my only options that multiply to 5 are 5 and 1. My only options that multiply to 2 are 2 and 1. So when we start this out, it has to be a 5x and it has to be a 1x. Now we're going to have to guess with where the 2's go. So I'm getting my pencil out, put a 2 in the end and a 1 here. Well, 1 times x is 1x, 5x times 2 is 10x. Well, 10 and 1 cannot combine to give me 3, because that would be 11 if I add, and if I subtract I would get 9, so that doesn't work. So we're going to switch the positions of them and see if that changes anything. So if I put my 2 here and my 1 here, 2x, 5x, well, if I add them I would be 7, but 5 minus 2 is 3. So to get a negative 3, my 5 has to be negative. So it'd have to be 5x times negative 1 and a positive 2 times x to get a positive 2x. And then we check our last. Positive 2 times negative 1 is indeed negative 2. And then that's our final answer. Make sure that you have corrected all your problems that you put your first and last name on it and that you hand it in the back. And then you can proceed on to the warm-up and the notes for today.